Hello, Algebra 1 students, and welcome back to your Semester 2 final review. We are into the part of your final, it's kind of 20 through 30, give or take, that's going to talk about factoring. Factoring was really the huge theme of this semester. This first factoring problem comes from lesson 8.5. This is before we learned how to use the full box method. And so what's going to happen here with any factoring problem really is we are going to look at these three terms and see what they all have in common. That's really what you should do the first time anybody asks you to factor. Now, the way that I've had you set this up in the past is if you're just looking to see what they have in common, there's three terms. We're going to make a box with just three spaces. We're going to look at 27, and then I like to write out the x to the fourth as 1, 2, 3, 4 x's. And then we have negative 36 x times x, and then 45 times x. So if we're looking to see what they have in common, we should be able to tell that they all each have just a single x in common. Right? We can't take more than one x because this guy at the end only has the one x. So we are going to factor out an x from each of those. What does that leave? Well, we had three x's here, so that'll leave us an x cubed. This will leave us an x and nothing here. We do, however, have to focus on those coefficients, those numbers as well, and we have to think, what do 27, 36, and 45 have in common? Now, because you probably won't have your factor sheet for the final, we can use the multiple choice answers to help us. You'll notice that they have 9s out front and 3s. Let's focus on the largest number first, because fully factored form takes out the greatest common factor. So let's see if a 9 goes into all of these. So if I divide out a 9, 27 divided by 9 is 3. Negative 36 divided by 9 is negative 4, and 45 divided by 9 is 5. So it seems like 5 did go into all of those. If I got any decimals when I was dividing, you'll notice there's no decimals up here, the 9 wouldn't have worked and we'd have had to go back to 3. But what we've done here then is we've put this into factored form. We have this 9x, and we also have this guy up top, 3x cubed minus 4x with a positive 5. Okay, now, they call this fully factored form. In Algebra 2, we're going to learn this is really not fully factored form. Traditionally, fully factored form has sets of parentheses that only have x to the first power. So this looks pretty factored, but I see an x cubed over here. For our intents and purposes, though, if we have an x cubed and you look at the answers, and the answers have the x cubed as well, you're fully factored. So don't stress about factoring any further here. So looking at this guy, hopefully it matches an answer. 3x cubed minus 4x plus 5. It looks like we've got to be A, right? Don't choose B. They have that fourth power hiding there. And we know it's not C and D because of the 3's. So there we go. It's looking pretty good. You could have found this answer a second way as well. You could have gone through and you could have taken the number that's out front and multiplied it to get to the inside, right? And we'll try to color coordinate this. 9x times 3x cubed, well 9 times 3 is 27, and x times x cubed is x to the fourth. 9x times negative 4x, 9 times negative 4 is negative 36, x times x is x squared. And last but not least, 9x times 5 is positive 45x. Right? With any problem that's in factored form, you should be able to multiply it back out, and it better match what you started with. And if it does, that is probably the right answer. So again, we had the correct way to do it down here. We had another way to check our answer up above. Nothing too terrible. Thank you as always for tuning in, and hopefully you're finding success on that final.